Hmm. Hello, assalamu alaikum, sasakal, namaste, vanakkam, intro. You know myself, Tofik. I welcomes you to the beautiful channel Added, where we study preparation for NEET and mains. So this year our target is 2026 NEET and mains. So without wasting any time, let us start our new course which we are starting from today. Okay, so our course we are starting with motion in a straight line. So we are studying first chapter here, motion in a straight line. I know before studying motion in a straight line, we must know about vectors. But already vectors has been uploaded. If you want, you can check out that vectors. Okay, if you are not studying vector, kindly don't see these topics. Vectors once finished, then only see this, because without vector you can't understand anything here. Okay, so let us start our first chapter, motion in a straight line. Now, before that motion in a straight line, few things are there which we need to discuss. For example, okay, see, motion in a straight line and motion in a plane comes under the kinematics. So, what is mean by this kinematic? Kinematics means here we study about motion without knowing the cause of motion. We don't want why the motion is starting, why it is stopping. No, we just don't want. If a car is moving, we just study about car is moving. We won't say why it is moving, who is pushing. No, no need. Just if car is moving, then study about that motion. Car moving. That's all. Kinematics is a branch of physics where we study only about the process. We won't study why it is happening. Okay. In this, we will study motion in a straight line and motion in a plane. Okay, so here in this one we study motion in straight line and next one is motion in plane. Basically your first chapter and second chapter you can see. Yeah, fine. So motion in a straight line and plane together you will get good questions, and from here 8 marks overall, 2 plus 2 8 marks is confirmed for NEET, and you will get one question confirmed for the mains also. Okay, so without wasting any time, if I start motion in a straight line, before that we must know few things about motion. See, few things about motion means motion. What do you mean by motion? Or when you say a particle is in motion. For example, say I am standing here. It is my initial point. If I change from here to here, I have changed my position. It was my initial position. I reached here, final position. So there is some change in this position, right? Then only we say there is motion. When we have change in position, then we say body is in motion. So when it is motion, when we have change in position. Agar a body, see, if one's body has change in position, then we say it is in motion. Now this motion, we have three kinds of motion basically some basics. So first thing we have one dimension motion, and next one we have two dimension, and then we will study about three dimension motion. These are all the kinds of motion which we will study. So in this your first chapter, motion in a straight line, we will focus only on 1D. Now basically what is this 1D, 2D? Now when we have only change in one axis, for example, see, when your car is moving, see, no, leave the car. Just see, I have a body, I can go like this, I can go like this. When I am moving only in one direction, whether it is like front or whether it is like back, then we call it as one dimension. Or you can say, when a body is moving only in one axis or with respect to one axis, whether it is front or back, like this, I am going here, I can go back. Or else when you drive a car, you can drive a car forward, you can drive car front, or you can drive car backwards. Okay. Now similarly, so when we have two dimension, Two-dimension process, na? Very simple. A particle or body covering both the axes. Both the axes. See, when a body is covering both or two axes. So best example for this, what is a ball? Yes, cricket ball. Cricket ball. Now why ball is the best example of two dimension? Now see, if you take a ball, one ball will have a motion like this. So at every point, if ball is here, it has two axes covering. If a ball is here, it has two axes covering. If a ball is here, it has two axes covering. If a ball is here, it has two axes covering. So every point in every ball at every point has two axes. That's why best example for two dimension is ball, cricket ball. Now three dimension, when the particle covers all three dimension. Very simple, three dimension and the particle covers all three dimension. So best example for this, you can say kite, patang, kite. So when kite is on sky, it can go like this left, it can go back, it can go like this, downside, upside. All the direction kite can go. That is why we say kite is the best example. Or you can say submarine, which you will see inside the water, under the water. Submarine, it can go like this, or it can go like this, or it can go like this. Submarine is the best example for three-dimension motion. These are just a brief introduction. Okay, what do you mean by motion, and what are the types of motion you will see. Okay, one dimension, two dimension, three dimension, and what do you mean by kinematics. Okay, hope you got it. Now let us continue. Okay, so let us continue this one with a small basic but very important topic called as frame of reference or reference point. Frame of reference or reference point. Frame of reference or reference point. So what is this frame of reference or reference point? So basically frame of reference is very simple. Okay, the point or the frame from which you observe any motion. For example, just imagine you are sitting in your room and comfortably seeing in this phone. Now according to you, just tell me one thing, are you moving? Are you moving? Sir, no sir, if you are moving, then why will you sit like this? No, right, you are not moving. According to you are not moving, because according to you earth is not moving, according to you. But if your friend, if any of your friend sitting in moon and observing you, how he will see you? He will see that you are moving. Slowly you are rotating. See, same point, you said that you are not moving, but your friend who is sitting on moon, he is saying that you are moving. What's the difference here? Or one more example, just say you are traveling in a car. When you are traveling in a car, you are sitting. According to you, you are not moving, you are just sitting like this, sleeping. You are not moving according to you. But the one who is standing outside the car, or one who is standing in the tree, standing near the tree and observing the car, what he will say? Car is going, zip, 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 car is going. But according to you, you are not doing anything, you are just chilling, sitting inside the car and chilling. Why? See, same situation. According to you, you are sitting and chilling, you are not moving. But according to the person standing near the tree, you are moving. What makes the difference here? Main thing. That is only we say frame of reference. Or else, I will give the best example. Just say, let's say it is one train ka dibba, or else train. Hey, okay, adjust train ka dibba. Thoda adjust kar lijiye. Train adjust. So in this, there are two friends sitting. La la la. So let's say this friend name is Sheila. Okay, this name is Ravi. This name is Kishore. We'll take names like this. So, this process, see what's going on here now. Sheila is a girl. I mean, Sheila is a girl. Then where is this hairs? Let us draw the hairs. She is happy. She is happy. But these fellows are sad. Because they are leaving the Sheila and they are going. So they are very, very sad. Okay, now let us come to main thing. Sheila has came to drop these two dirty fellow in railway station. Imagine. So they are sitting in train. Sheila is standing outside. Now what happened? This train start moving with velocity, whatever the velocity. If you ask Sheila, what Sheila will say? After some time what happened? Sheila will be standing here only. Sheila pila gila. But this train has moved like this. Sir, dead bodies are better than this. Yes, dead bodies are better than this. Okay. Now, if you ask Sheila, Sheila describe the motion. She will say, Tawfiq sir, I am in rest only. The two persons, Kishore and Ravi, they are moving away from me. One thing. What Sheila said? I am at rest only, sir, but two dirty fellows are moving away from me. Matlab ke, she is standing here on the station, platform. Train is moving. If you ask Sheila, she will say like this. If you ask Ravi who is sitting like this, Ravi, if you ask, describe the motion, Ravi will say, sir, I am and Kishore both are sitting. So, me and Kishore both are sitting, sir. But Sheila only going backwards. I think you have observed when you are sitting in a train is moving, but according to you, you are at rest, everything is going backwards. Similarly, Ravi will say, sir, me and Kishore is at rest. Sheila only moving backwards. When you ask Kishore also says same. Sir, me and Ravi is at rest. Sheila only moving backwards. See, single situation, point of observing is different. And from which point they are observing, from that point describing is different. That is why we say frame of reference is very important. Okay. Now one more example if I take. See, for example, you have one car here. This car is here. After some time, this car like this, thoda motion. Can you say whether this car has moved or not? Sir, how can we say this car is moved or not? We can't say. Yes, we can't say. But now I think you can say, if I draw like this. Yes sir, this car is in motion. Now how you say this car is in motion? Because at this point it is at 0, 0. After some time it is moved. If I take here 0, 0, it is moved till here. This distance it covered. That's why we say it is in motion mode. See, this is only our frame of reference. When we have frame of reference, we can describe the motion. When we don't have frame of reference, we can't say motion is happening or not. Okay sir, this we understood. Now how to take frame of reference? See, frame of reference is very simple. From where you observe the motion, that point is your frame of reference. For example, in this situation, this point will be my frame of reference. And where I consider frame of reference, now the point I am observing, that point values I will take as 0, 0. Now here I am seeing 0, 0. Car moved at 4, 0. Matlab ke car has moved 4 meters. That is why wherever see in any question, if they are given like this, we just take frame of reference from where we are observing, that is 0, 0. From this body is going, we will observe the distance or displacement or time or whatever it is. Okay. But one thing, frame of reference or samajh aaya sir, frame of reference is very easy. Is it done? No. To observe a motion, how much frame of reference is important, same way time is important. If you don't have time, then how you can say motion is happening or not? With respect to what? With respect to what? What लग गई हमारी तो? With respect to what? With respect to time. See, when you have time, okay, I'll say, okay, Sheila, in 1 second she is here. Sheila, in next second she is here. Sheila, in next second she is here. If time is not there, she is here, she is here, she is here, she is here. What is this? Nonsense, right? That is why when we have frame of reference plus time together we call it as reference. Okay, so axis, coordinate axis and time, which is very bad nowadays. Can't do anything. Okay, so axis, coordinate axis and time together we call as frame of reference. Okay, I think you got this one. And one more thing, motion. I said what do you mean by motion? There is one more term called as rest. See, rest means very simple. If I am here, 1 minute I am here, 2 minutes I am here, 3 minutes I am here only. I am not changing my position with respect to time. That is our rest. A particle, see, write down. See, everything I can't write on the board. So you write down, take down the notes. If you are thinking it is going fast, reduce the speed. Or if you are thinking it is going slow, increase the speed. So write down, rest. When a particle or body, when a particle or body is not changing its position. When a particle or body is not changing its position with respect to time, then it is called as rest. With respect to time, then it is called as rest. Now, I will give you the best beautiful sentence of your entire chapter. That is, write down this one. Rest and motion is not absolute. It is relative. मतलब कि it is relative means it is depends on observer. Means rest and motion. When body is moving or whether it is in rest, it is not absolute. मतलब कि I am saying कि body is moving. It is not necessary that you will also say कि body is moving. No, it is not absolute. It is relative. Relative means it is depend on observer. मतलब कि the one who is sitting inside the car, the one who is standing outside the car, the one who is sitting inside the train, the one who is standing outside the train. It is relative. It's depend on observer. It is not absolute. Okay. Hope take down all this if you want. Write down this fast. Okay. Reference point over. Now let us jump to the main part. Starting. See, इसका मतलब ये नहीं कि this is not important. No, it is very important. Yeah, I forgot to say one more thing. We take frame of reference with respect to question. If in the question they have mentioned that frame of reference are the point where you are seeing the motion is on the top of the building, you will take that point as a reference. If they say somewhere else, now you will take that point as a reference. But if they have not mentioned any point, then we take ground or earth as our natural frame of reference. Especially, they won't mention in the question. If they are not mentioned in the question, it is direct ke we have to take earth or ground as our frame of reference. Okay. Now let us jump to main thing. Our distance and let's say it is a displacement. Distance and displacement. Basically, we know all the time. One more time, a quick revision. See, distance means the actual path covered by a body. मतलब क्या है? Let's don't worry. Distance means the actual path covered by the body. It is mean by distance. Now displacement means the shortest distance between the initial and final points. So displacement means shortest distance between initial and final points. Now one example if I take, समझो, if a person is starting to move in this direction, he moved like this. Let's say length L he moved, length L. Now after some time what happened? Now he took U-turn and he traveled back till L by 2. Till L by 2. So when person started moving, it went like this, then turned, then came here. So a person started moving in this direction. After some time covering L distance, he stopped, he take U-turn and come back to here. He stopped. So this will be our initial position and this will be our final position. If you ask what is the distance here, let's say A, B, C. So here the actual distance of this person is distance AB plus BC, which means distance L plus L by 2, which is equals to 3 times of L by 2. But when you ask displacement, see displacement, if you say it is the shortest distance, this shortest distance. So this shortest distance is only our displacement. So let's say here the points are 0, 0. Here you have L by 2, 0. L by 2, 0. So here shortest distance is our L by 2 final minus initial. Final position minus initial position. Shortest distance. See, so here we got our displacement as L by 2. Same one motion, here distance is coming all this one and displacement is only this short distance. Hope you got it. Hope you got it. Now we got distance as scalar quantity. Scalar. Whereas displacement is vector. Vector. And remember one thing, okay? Your scalar, your distance always positive. Positive. But your displacement positive, negative, and can be 0 also. But if a particle start motion, then distance can never be 0. So अगर एक particle, see, if a particle started moving now, then distance can never be 0. See, how I say? I am, let's say I am the person. I started moving. I move like this, till here. I have covered some distance. So it is my distance, it is my displacement also. Now I come back like this. I came here. My distance is L plus L, 2L. My displacement is 0. See, my distance, if I move a little also, my distance cannot be 0. I have moved 1 meter distance. But displacement can be 0. Displacement can be positive. Displacement can be negative also. I will say why it is negative. See, why it is negative? See, if a person starting from here, it moves like this. Displacement positive. He turn, he come back till here. Displacement 0. Again he went like this. Displacement negative. Like this. And one more thing, This is measured in meter and this is also measured in meter. And this dimension will be like M0, L1, T0 and same for this also. Hope you got it. Okay, if you want write down first, we have still many more points, guys. Woo. Okay, hope you got it. You got it. You got it. Yes, hope you got it. Now, few more points. Okay, if a particle start moving now, then we can write like this. Okay, magnitude of distance is always greater than or equals to. Once again, displacement. I think spelling is wrong. Where is the register? Where is the register? अबे किधर गया बे? Yeah, मिल गया यार. Okay. See, a particle start moving. Agar a particle is moved, na, then your magnitude of distance is always greater than or equal to 0. When it is greater, when it is equal to see, a particle is there. It start moving like this. Now, if it is straight line motion, matlab ke particle is moving like this only. Straight line. Straight line. If a particle is moving in straight line, single straight line, then your distance will be equals to displacement. Like this. Now, similarly, if a particle is started moving, it went like this, and again it turned it back like this. So here, shortest distance is this one. In this case, our distance is greater than our displacement. And one more thing, displacement can never be more than distance. Whether it can be equals to or it can be less than 1, it can never be more than this. Okay, hope you got it. Now one more thing, I said one small thing, okay? Distance is a scalar quantity whereas displacement is a vector quantity. Yeah, I need to justify this one. Your distance also has direction. But unfortunately, we won't consider the direction. Why we won't consider it now? See, for example, one person starting motion from here and he went all over like this to end point. He went like this to end point. Now, if you ask what is a displacement, what you will say, sir, displacement is from here to here. A proper direction is there. But distance is all this room. So why distance has no direction? No? Because if you take this point, my direction is this side. If you take this point, my direction is this side. If you take this point, my direction here. If you take this point, direction here, direction here, direction here. See, every point has some other direction. What is this market? Fish market. Many directions is coming. We can't define a proper direction. What is the direction of distance? But for displacement, unidirectional. Distance, multidirectional. Multi-directed person. So, we say, see, distance also has distance also has direction. But we can't define indefined direction because see how much direction it has. But displacement has a proper direction. That is why we say displacement is a vector quantity, whereas distance is a scalar quantity. Oh, if you want, you can write down this also. Sahi hai. Yes, good. Fine. Now let us see a few more good, great examples of distance and displacement. Okay. Now, if I take a circle like this, circle की तो बड़ा बेनी को दिया. Okay. If I take a circle and this point as O, so Fine. Say, if I have a circle, please adjust. It is not circles. I also agree. I also agree. You are feeling very bad. You are feeling to scold me, but control. Adjust. So if it is a circle, and this point is point O for our imagination. So let's say this point is A, this point is B, and this point C, and this point is D. When you move from A to B, then your distance and your displacement. What happens to these two? Distance and displacement when you move from A to B. When you move from A to B, your distance will be like this overall length, arc length, side. So let's say this has radius R, this has radius R. Now when you are moving from here to here, you are covering this path length. That path length we write S is equals to R theta if you are know. Or else if you don't know, we say this path length or arc length S is equals to R theta. Whereas S is equals to R is a radius, pi is in radian, pi by 2 because it is 90 degree, pi by 2. But our displacement in this is this one. It is our shortest distance. If it is R, then it will be root 2 times of R, Pythagoras theorem. So my displacement will be root 2 times of R. Now when I move from A to C, my distance will be R times of pi. Whereas my displacement will be 2 of R because R, 2 of R. When I move from A to D, my distance will be R times of 270 degree. 270 degree, 3 pi by 2. Whereas my displacement will be this much. See, displacement. ये हो जाएगा, this will become my displacement which is downside direction. So I can write root 2 times of R downside. When I say I move from A to A, then my distance will be R times of 2 pi. And my displacement will be 0. See, when you move in a circle, these are all the things you will see. Arc length, distance, displacement. Now, at this point, displacement is here, upside direction. When it is this side, displacement is downside direction. When we write in vectors, we can write very easily. We can represent in vectors. Don't worry, we will learn slowly. We will learn in iit-jee. Now, it is a main thing, distance and displacement. Now, there is one more small thing. Okay? If you cover 90, then it is very good. You can very easily calculate. But if you cover a point from here to here, if you are covering a particle distance from here to here, now what is the distance and displacement? Very crazy. But say, Abhay yaar, 90 degree anyone can say this, we don't know angles. Yeah, if you don't know like this, what we do, we know this is our arc length and it is our displacement. If you want to write still more clear, then we can write like this. Yeah, distance and displacement. So first thing what we do, we'll put a line like this here. And we know this lines, it is our R and R only. Let's say this distance is X and it is also our X. I want this XX only. And let's say it is our theta by 2. It is our theta by 2. When I ask you to find here distance, you can write distance is equals to R into theta because R is radius, theta is distance covered. Matlab overall this distance covered. Fine. But the main thing is displacement. Yeah, displacement. Sir, S is equal to R theta is easy. R है theta cover. See, it is theta 2 plus theta 2 is theta only. So this will be S is equals to R theta. Very easy. Now the main thing displacements are this displacement क्या है? Displacement. So when we are seeing for displacement, Here we use our vectors. How we use vectors? See, if you focus here, we have a line like this. R, here theta by 2, here also theta by 2. And this side x and this side x. If I break this R will break like this. R cos theta by 2, R sin theta by 2. Or cos theta by 2, R sin theta by 2. Which means I will get here R sin theta by 2. And this side also I will get R sin theta by 2. If you focus on this both upside and downside, if I compare both upside and downside, I can write 2 times of x is equals to 2 times of R sin theta by 2. Then this 2 and 2 cancel. Then I will get x is equals to R sin theta by 2. If I want displacement, I will write like this. Hope you got it. So when you want to find this two distance, this entire distance, this displacement, we got that displacement formula as 2 of x is equals to 2 times of R sin theta by 2. When you want to find this sin theta value, we can write like this, and I can say ki x by R is equals to sin theta by 2. All the things. A quick revision for you all. See, when a particle travels from A to B, all the distance displacements are here. Now it is fine, but it is covering some arc length, only some arc length. Then here, what is the distance and displacement if you ask? Distance is s is equal to r, that is fine, completely all right. But displacement jo A hai, x and x, this we can't find. So what we do? We use k, displacement is this only sir. It is r there. It is theta by 2. I can break this r into r cos theta by 2, r sin theta by 2. R cos theta by 2, r sin theta by 2. This 2 and this 2 are in same like this. So I can add this 2. I can write like this. I can find displacement like this. 2x is a displacement only. I can find like this. Okay. So अगर मेरे को angle चाहिए, if you want angle, I can just send this 2 downside, sorry, this r downside, sin theta by 2 is equals to x by r. Hope you got it. Kindly write down. Okay, students. I wanted to do I have planned today we will finish distance, displacement, velocity, average velocity, speed, everything. But after recording, I am seeing a time is 10 o'clock now. So and I am alone in a room. So I will do it tomorrow. So tomorrow don't miss the class. We will study about velocity, average distance, average speed, instantaneous speed, all speed and velocity concepts we can do tomorrow. Then acceleration, then turning problems, U-turn problems, not Newton U-turn problems. Then we can say we'll discuss about equations, kinematic equations. Then we can comfortably end this chapter. Graphs also there, graphs also we will see. Then we'll stop this chapter. It will take a few days, maybe this week or a few more days. Fine. So kindly, if you are watching till now, just comment how is the video, anything voice or quality, something to be changed. Your comment will help us very good. Okay, and stay connected with us. If you have any doubts, any queries, don't hesitate to comment. Okay, we'll personally reply for your comment. And if you want notes of this class, all for mains and neet separate, you can just put a message ki we want notes for you. Then I will give an alternative for that. I will see, maybe we may upload in the Telegram channel or maybe I'll go to a YouTube group. Okay, so hope you like this. Hope you like this. We'll meet in next class. Till that, bye bye. Thank you. Allah Hafiz to all.